Do you want to create auditoriums, stadiums, or some other stage in 5 minutes, without complications? You've come to the right place. You'll have your perfect scenario. We come from the infinity of the universe, the place where all forms of matter and energy are born, governed by physical laws and constants, of which some earthlings with superior intelligence and great mental strength have been able to understand and transmit them to other earthlings. We have presence and experience of 5,000 billion years in large-scale projects at a universal level that most earthlings could not understand or visualize, since many are based on different types of matter, energy, laws, and physical constants. We have come to Earth to help all humans solve the biggest problems. In order to create an auditorium, we first have to calculate the isoptic. Remember to click on the Roswell mustache so that all the calculation systems are automatically displayed. The system will calculate up to 20 heights from the viewer's level, 20 distances from the isoptic point. You will be able to generate the graph of the isoptic curve. Likewise, the system will allow you to download a CSV file with all the coordinates of all the isoptic points of the entire theater, open-air theater, auditorium, or stadium automatically. You will only have to copy and paste these coordinates into your favorite drawing program and you will practically have your building or auditorium. With our new and advanced trigonometry and technology, we have managed to create different very useful computer systems to calculate the isoptic quickly and accurately, where the distances of the viewer are related to each new height obtained. It is very important to use this system to calculate the isoptic that you have a defined distance to the first spectator, D1, also a height towards the viewer's eye when seated, H1. You can average the heights of seats and people while they are seated to obtain it. Finally, define a height from the eye of the viewer sitting one row below to the projection of the view of the person sitting in the row above, which we will call K. As a result, we will obtain the heights H2, H3, H4, etc. from the viewer's level. Next, in the following system to calculate the isoptic, you will only have to enter the distance D1, the height H1, K, and the separation of the rows. The system will calculate up to 20 heights from the viewer's level, 20 distances from the isoptic point. You will be able to generate the graph of the isoptic curve. Likewise, the system will allow you to download a CSV file with all the coordinates of all the isoptic points of the entire theater, open-air theater, auditorium, or stadium automatically. You will only have to copy and paste these coordinates into your favorite drawing program and you will practically have your auditorium. Program to calculate isoptics with high scenarios. So, in the following system to calculate the isoptic you will only have to enter the distance D1, the height H1, K, the height of the stage AE, and the separation of the rows. The system will calculate up to 20 heights from the finished floor level, 20 distances from the isoptic point. You will generate the curved graph of the isoptic. Likewise, the program will allow you to generate a CSV file with all the coordinates of all the isoptic points of the indoor theater or auditorium automatically. You will only have to copy these coordinates and paste them into your favorite drawing program and you will have the isoptic and practically your indoor theater or auditorium. Remember, the mustache of Roswell. Don't forget to give us 5 stars if we have helped you. Once you have the horizontal and vertical distances of each eye of the person sitting in the first row of each level of the building, you can repeat the process and add the levels you want. You'll also be able to create auditoriums, cinemas, theaters, stadiums, or any other three-level stage, with or without high stages, quickly and easily. In the system you will only have to enter the distance, d1, the height h1, k, the height of the stage ae, the separation of the rows, the distance, d1-2 do.n, the height h1-2 nd.n, the distance d1-3 and the height h1-3 and the system will calculate up to 20 heights from the finished floor level and 20 distances from the point of the isoptic of each level of the theater or auditorium, as well as it will automatically generate a CSV file with all the isoptic points and coordinates so that you can only copy and paste it into your favorite drawing program. You will also be able to generate the curved graph of the isoptics automatically of the entire theater or auditorium. In the curved graph of the isoptic, you can see if you have errors. If you have, you can put new data and generate the graph again. In some cases, it is ideal to give the system time to calculate everything. If there is an empty field, it means that it has not finished. Now we'll do a 6-tier stadium as an example. You can enter data in feet or meters into the system. Remember to click on the Roswell mustache. Let's enter the d1 distance. If we want it to be an exact 15 meters from the point of the isoptic from the level of the playing field to the first row, we have to take into account the distance from the center of the eye to the rest of the foot of that seat. In this way it will be exact. Then we introduce the data of 15.6744 meters. The height h1 is the height from the floor of the seat to the center of the eye. In this case, because it is the first row, you must take into account the height of any other step until you reach the first row. In this example, there are no extra steps, so only the distance from the floor of the seat to the center of the eye is taken. It would be 1.1594 meters. The distance k is the height that starts from the eye of the person sitting in the bottom row and meets the projection of the visual of the person sitting in the top row. This is one of the most important data that a designer needs to make his stadium perfect and also economical. In this example, it will be 0.15 meters. The separation of rows is simple. You must have the total width of the seat with the person seated. In this example it is 1.09 meters. So if you want a separation of 0.80 meters, you must put in this field the data of 1.89 meters. The system will allow you to generate the graph and download a CSV file with all the coordinates of the first level isoptic. This is the CSV file. It's best if you open the file with a run-of-the-mill notepad. In some drawing programs, you have to copy the coordinates from point 0, 0 to the next point 0, 0. Doing so, it will have its effect and you will be able to paste all the dots or seats automatically. If you use a spreadsheet from a professional program, in some cases it can come out without the comma in the middle of the numbers. Then you will have to concatenate all the coordinates. It's simple. Put the pointer in C1 and put the concatenate function. You must specify cells A1 and B1. Also put the comma that will separate the numbers. You click accept and that's it. Copy and paste and finish your work fast. A little reminder, the concatenate function may vary from program to program. In your favorite drawing program, all you have to do is choose a dot or a block of a person sitting in a standardized professional seat. Of course, the person's block must have its point of origin in the center of the eye and be located at point 0, 0 of your drawing. Then, all you have to do is paste in the coordinates and you'll have practically your one-level stadium. Remember, we'll teach you how to make a 6-level stadium. You will be able to check that the data you entered in the system will be reflected in your preferred drawing program. You can review everything you want. However, the system does not fail if you use it well. You can be sure that what you do in our systems will be well done. To do the second level, always in the same line as the first level, is also simple. Place yourself in the last row of the first level of the stadium, place a separation of 2 meters, also place separation if you wish in the first row of the second level. Once the seat is located, you are going to take a long line from the center of the eye extended upwards and downwards. In the lower seat, which is the last of the first level of the stadium, you will draw a line from the center of the seated person's eye to the beginning of the point of the isoptic. Then you will extend this line until it meets the extended line of the first row of the second level. Set a distance from this point upwards of 0.30 meters. That's where you'll place the seat. Remember, the point of origin is the center of the eye, and you'll be able to get the d1-2do.n distance, which refers to the horizontal distance from the point of the isoptic to the center of the eye. Finally, you can also get the height h1-2do.n, which refers to the vertical distance from the center of the eye to the level of the floor of the playing field, from where the point of the isoptic is born. Now all you have to do is enter the data into the calculation system. The distance, d1-2do.n. According to the previous design, it is 55.5744 meters. Height h1-2do.n is 9.8545770 meters. The K distance for this level will be 0.20 meters. The separation of rows will be 0.70 meters, so you will have to enter the data of 1.79 meters. Remember, when entering the data, wait a little while for the system to finish calculating automatically. You will also be able to generate the curved graph of the isoptics again, as well as the CSV file, with all the coordinates. Don't forget to give us 5 stars. Now just copy and paste the coordinates into your favorite drawing program. By pasting the coordinates with the origin in the center of the eye of the seated person's block, you will have practically the second level, and it is only necessary to complete a few lines. When you're checking the isoptics and row spacing of this second level, everything on this second level will be perfect. You will be able to check that the data you entered in the system will be reflected in your preferred drawing program. You can review everything you want. However, the system does not fail if you use it well. You can be sure that what you do in our systems will be well done. Now let's do an example of a third level, but now on the mezzanine. You need to define the size of your stadium. In this case it will be 120 meters and a visual height that the last people on the second level in front of them will be able to see, in this example 50 meters. With this, you will be able to take projections from the center of the eye of the person sitting in the last row of the second level to the isoptic and define a visual field that this person will have sitting in the last row of the second level. With this defined, you will be able to place your mezzanine or third level of the stadium, always taking projections from the center of the eye of the person sitting in the first row of the third level to the origin of the isoptics. You'll get the distance d1-3r.n and height h1-3r.n. Now you will simply have to insert the data. The distance d1-3r.n is 55.7744 meters, the height h1-3r.n is 27.568801 meters, the distance k in this example is 0.25 meters, and the row spacing is 1 meter, so you'll need to enter the data of 2.09 meters. As in all the previous examples, you will be able to generate the curved graph of the isoptic and download the CSV file with all the coordinates of the third level of the stadium. It's all too easy. Now just copy and paste the coordinates into your favorite drawing program. By pasting the coordinates or blocks you will automatically have your third level of the stadium. It is only necessary to complete a few lines. This is the explanation of the systems, but with this you will be able to build an entire World Cup or Olympic stadium of great magnitude quickly in minutes, exactly and almost perfectly. You can enter the data you want and try an infinite number of other design possibilities that can better adapt to what you need. From a large stadium like the Santiago Bernabéu in Madrid, Spain, or you can also give free rein to your imagination and build the best stadium for a Super Bowl. Remember, the closer the next levels are located to the source of the isoptic, the larger the steps will be, and the farther away, the smaller the steps will be. You will be able to check that the data you entered in the system will be reflected in your preferred drawing program. You can review everything you want. However, the system does not fail if you use it well. You can be sure that what you do in our systems will be well done. Welcome to the new century of more accurate, faster, easier, and therefore more creative stadium planning, as well as more accurate, faster, and simpler stadium construction supervision. We're here to help you untangle the world. Let's be a team and build a better planet Earth.